Perfect. Yeah, thanks for the introduction and thanks for the opportunity to give that presentation today. So my talk is entitled Empirical Modeling of Farm Technology Adoption and Impact. So what I really want to talk about is how can we analyze, how can we study under which condition farmers adopt technologies, and also how we can study what economic or environmental effects those adoption will have. What is the aim of my talk? So what I wanted to achieve is, beyond simply reporting on our ongoing work or our planned work in the future, I also wanted to start a bit more broadly trying to enhance the understanding of the economic perspective that we take within FINOROP and talk about the challenges that we face with the aim to increase the interdisciplinary understanding, I would say, and with this trying to increase chances that we could identify possibilities for interdisciplinary cooperation or collaboration. When preparing for the talk, that kind of reminded me of that drawing here from the New Yorker, which I think has great parallels for also interdisciplinary work. Because I think for me as an economist within FINOROP, I do have a pretty good overview about our economic activities within FINOROP, but this is only to a lesser extent true for the other activities, the other disciplines within FINOROP. And I could imagine that this maybe holds in reverse also for our economic activities. And I wanted to try to use that talk, this seminar series here, to talk a bit of our about our Manhattan, so to say, our economic work with the aim, as I said, to increase the interdisciplinary understanding and potentially also increase the chances to identify possibilities for exchange. So what are, from my perspective, the important components in order to achieve our shared FINOROP aim to enhance sustainability of agriculture with novel technologies? And from my perspective, there are two areas, two dimensions, two scales, if you want, that we can separate here. The first, I would say, is basically everything that happens in the lab. So everything that is basic research, tech development, field trials. And I would say that many of the activities within FINOROP take place in that area. But equally important for the effects of a technology on outcomes is what is happening at the farmer scale or the regional scale. So here questions of adoption, usage, indirect effects or aggregate effects matter. And what we are focusing at as economists within FINOROP is really those scale or those dimensions beyond the lab. So basically everything that happens beyond the field trail, beyond the experiments, beyond the research station. What are examples for those elements here? So in terms of adoptions, we are pretty much interested in the determinants of adoptions, or under which conditions farmers adopt technologies. In terms of usage, we are interested in the frequency, the intensity of usage of technologies on farms. We want to find out if farmers use the technology as a complement or as a substitute to existing technologies. In terms of indirect effects, we're interested in understanding induced structural or behavioral changes caused by the availability, by the adoption of a novel technology. And in terms of the regional scale, the aggregated effects, we are pretty much interested to assess to what extent or what is the overall effect of the individual farmer's decision. So really the question, to what extent does the overall effect differ from the sum of the individual parts due to feedbacks, due to interactions? So we're interested in the regional adoption rates and spatial and temporal dynamics and these things. I also would say that the questions differ quite fundamentally between these areas. So I would say on the left, the primary question is how to move the yield potential. So how can we achieve an increase in yields by novel technology breeding better management, and also to what extent can we assess the yield potential? So at least that, from my understanding, would be the questions at these lab scale. While on the right side, the question is really to what extent is that yield potential realized by farmers, or more concretely, so probably we are not that interested in the potential. So primarily what we want to answer is the question simply, what is the effect of a technology on outcomes? So that, I think, is the core question. And then even more important, building on that, the question, how can we influence the effect of a technology on outcomes via policies, or also providing feedback back to the technology development by technology adjustment. So that is basically the first point that I wanted to make, that our focus is really everything that happens beyond the lab, beyond the research station. So what do we, and the core question is what you have below here, what is the effect of a technology on outcomes? So what are the key challenges when we want to answer that question? And the question is basically a causal question that we want to answer, and I've adopted here kind of similar to these structural equation models, also here in similar notation. So what we really want to answer is, or determine, is the effect of tech adoption on outcomes. I've already mentioned that this is a bit more complicated because it also depends on the tech use, which is in between, and it also depends on the indirect effects that we need to take into account and need to consider. So in an ideal world, if we would want to answer that question here, we would need to have data on all of these elements. And importantly, tech adoption and usage would need to be randomly assigned. So basically farmers would need to flip a coin to decide how they use and if they use the technology. If that would be the case, and would be very similar to an experimental settings, and there would be no challenge at all. So we could simply answer that question quite straightforwardly. However, that is obviously not the world as it is. So the first challenge that we are facing is that tech adoption is not randomly assigned, and it depends on all kinds of factors that needs to be included, or that needs to be considered. And what we really need to solve is the question of how to identify causal effect from non-experimental data, so from observational data. This is something that we as economists basically always face. So it is a challenge, but it's not really a new challenge in that sense. And there is also all kinds of, or entire arsenal of approaches, of econometric approaches, and recently also machine learning approaches developed to address that challenge, I would say. Nevertheless, it remains a major challenge. The second problem, however, and that's probably not that apparent to everybody, is that we face a severe data shortage, I would say. So ideally, we would need to have data on all of these four elements, but in fact, we have hardly any data on any of them. So the data on tech adoption is really limited, only available from survey data primarily, which has a very local focus, is usually not spatially explicit, has usually not really a temporal dimension, and provides little information on the intensity or the frequency on usage. So it usually doesn't provide information on the tech use. We also have little data on the outcomes, so on yields and indicators. That's probably a bit better, but at least in combination with tech usage, that is really limited. So we have hardly the case that you have information about the usage and the outcome in combination. And the same for indirect effects. Here we also have little data, and I think also there is a limitation in terms of the methods and the theory maybe as well, in terms of how we study these indirect effects. So that is basically what we are operating at, and the challenges that we need to address in order to answer that question. So what are ways forward? And I think in principle there are two options. So that is either we stick to empirical work or we move to simulation models. And in Phenolab, I think we do both. So for empirical work, the first thing that is important to recognize is that we need to focus on existing technologies, because we cannot study something empirically that doesn't exist yet. Obviously, we need to exploit data sources where they are available where possible. And I think that is important, we need to improve our databases using surveys, but also using new sources and new tools. And that is also important to understand or explains what is following in our ongoing work, because that is basically the part we're primarily focusing on at the moment. I think we need to leverage interdisciplinary collaboration, and I think that is a connection to the seminar presentation here today. And finally, we also, but that is more internal, I think we need to improve our tools, for example, to study indirect effects or also spatial interactions. And alternatively to empirical work, we could go for simulation models, which is something that is also done in FINOROP, so the agent-based model by Sebastian or Maria, or the single farm simulation models, farmed and Fruchtfolge, that Christoph is working on in CP6. Those methods are probably do have a less severe data demand. However, in order to not stay completely theoretically, they also need to ideally have a strong empirical backing. So ideally, we would be able to combine both of these worlds, and that is basically what we are trying to achieve, so that we can leverage the advantage of both of these worlds. Okay, so that as a background to maybe understand a bit better why we are dealing with certain aspects that you will see in the following. And here, as an overview, the topics that we are working on, and here just to show you that with these different topics that I would talk about in a bit more detail in the following, we are addressing to a certain degree all of these points that I have mentioned before. So the first topic is the PhD thesis or the PhD project of Anna Masfeller, and she's looking at the adoption and usage of mechanical reading technologies, and particularly on existing mechanical reading technologies, as you see here on the picture, for example. And our aim is that we want to look at these technologies and aim to understand the objectives of farmers. So why do farmers use that technology? Do they use that out of economic concerns or out of environmental concerns, or because there are no technical alternatives? And we think that studying these objectives is interesting in its own rights for that technology in order to promote adoption of these existing technologies, but also because we believe that we can draw useful conclusions also for future technologies that are developed in FINOROP, for example, our autonomous reading robot. I think also here it is interesting to know what objectives the farmer is addressing. So does he want to address economic concerns, or does he want to address some environmental concerns? Secondly, we also wanted to study the role of spatial peer effects for adoption. So really the question, to what extent does it matter what my neighbors are doing? So if they all use mechanical reading, then do I also start using it? And importantly, we want to empirically quantify these neighboring effects. And again, here, I think that is interesting in its own right, but also interesting for studying or simulating the diffusion of future autonomous reading robot technologies, for example. The approach that we take is that we want to use existing survey data in cooperation with the Institute for Sugar Beet Research, that was mentioned also in the previous talk. And so primarily for the first aim, and for the second, we are planning to do an own survey in addition, so where we try to develop a new tool where farmers indicate on the map, which is what you see below, indicate on the map on which fields they use a certain technology, and also where neighbors use a certain technology, so that we can then use spatial econometric approaches to study the peer effects and the neighboring effects. In terms of FINOROP cooperation, that is something that we are currently working on together with Ann-Kathrin Malan, who is in FINOROP, as well as heading the IFZ, and I think that is for us a really useful and helpful collaboration. The next topic that I want to talk about is the PhD project by Elin Martensen, and she's focusing on indirect effects of technology adoption, and specifically what she's looking at in the moment is that we want to empirically test the presence of indirect environmental effects using or looking at the example of robotic milking systems. Robotic milking systems are not a core phenorob technology. Nevertheless, we think that this is interesting to look at these because it is a robotic system that is already widely adopted in the farming sector. And because we believe that is an interesting example to study indirect effects, because we assume that this technology is primarily used or adopted by farmers because of labor saving concerns. But we think that it is very likely that it also has, can also have lead to indirect changes, behavioral structural changes on the farm that can also then have economic, environmental effects. And we believe that, this is an interesting use case to, first of all, study these effects and also develop our methods to quantify these indirect effects, for example, through concepts such as eco-efficiency, and also to conceptualize the indirect effects. We are using for that an existing Norwegian data set, which is also one reason why this technology is interesting, because it is one of the rare cases where there is a data set available on usage and also a rather large range of output indicators. And just here as a very preliminary result, what you see here in this plot is that that with the time of adoption, there is really happening something on the farm. So again, a technology that is primarily intended to save labor seems to be associated with quite drastic changes on the farm. So here in terms of the milk output, that seems to increase quite substantially at the time of adoption. In terms of the phenorob connections, there is currently no connection yet, but I think what would be interesting to us, and I think the previous talk was already a great example in that direction, I think what would be interesting for us is any approach to measure the environmental impacts in certain ways, so that we can use these measures in our study of the indirect effects, in our study of the eco-efficiency effects of technologies. The next two examples that I want to talk about are things that I'm trying to work on, or I'm working on, and that is the idea really to improve our existing data sources of technology usage. And the idea is to use remote sensing data to detect technology usage and as well as outcomes. And then use these data to study diffusion, spatial peer effects, again, similar to what Anna is looking at, and also to study the effects of technologies on outcomes. And that is something that I'm currently working together with Ribana, planning to develop a project proposal for that. And the core idea here is that we want to use deep learning approaches to detect technology usage from satellite data. And specifically, we're interested in seeing to what extent we can incorporate agronomic knowledge in these deep learning approaches, so using informed deep learning approaches, for example, information about typical working steps that happen on the field, and we wanted to see to what extent that can help in order to detect certain technologies or managements. Here, just as an example on the right, that is data that was also presented at the DigiCrop conference from Jill Dines. So for the US, this kind of data already exists. So they have data derived from remote sensing data on the adoption of low tillage. And they've used it also to assess the yield effects on that technology. And my plan is to use that data, so they've made that data available, and I wanted to use that data also to study peer effects, the adoption effects, the neighboring effects, which is something which I think is pretty interesting with that data, and something that is not done yet based on that database. The next thing, that's a smaller project I'm doing together with a student assistant, Alexander Fokart, who's doing the technical implementation. And the core idea here is that we want to measure the mechanization level basically of farms by measuring the distance between the tractor tracks in fields, because we assume that the distance is kind of a measure of the size of the machinery that the farmer is using. And we have, for North Rhine-Westphalia, we have these high-resolution autophotos available, and we're using some edge detection algorithm to measure these distances. What you see here is really preliminary results, so that is not validated in any sense yet, but I think you can already see that there is a certain, or the distribution, at least for me, does not look too unplausible in terms of the technology that we detect there. And you also see that there are some certain spatial patterns with the colors indicating different machinery sizes. So I think that is quite interesting, and we get that basically for entire North Rhine-Westphalia, also for a rather large time series. And that is, the idea is also to use that within FINROP CP6, so for the modeling work of Sebastian and Christoph. And then finally, something that I'm working on with Lin-Mei Zhang, who is supervised by Thomas Heckelei, and that is a topic that goes back to basically the original CP6 proposal, I would say. And the idea is here that we use deep learning approaches to build surrogate models of complex individual farm level models that are then used in agent-based models at a larger scale, so really addressing these upscaling questions. And that is something that we're collaborating with Jürgen Gall and his PhD student, Qifeng Wang. To summarize, I hope I'm still in time somehow. So what we're really focusing on is studying farmers' adoption and usage beyond the research station, with the aim to assess the effects of technology adoption, and finally to derive recommendations for policy or tech adoptions, how to influence these effects. The challenges is that we have very little data on that, and that if you work with observational data, so non-experimental data, you need to deal with non-random assignment and need to approach that, or need to be able to identify causal effects from these observational data. What is the approach? First of all, we want to improve our data sets, and that is what we are currently working on primarily. However, what we really want to get at is that we are able to identify these causal effects using our econometric approaches, but also using novel causal machine learning approaches, which I think are really exciting, particularly in combination with the remote sensing data, and pretty useful for our task. And then thirdly, we want to derive policy effects and policy conclusions. So this box here is basically where we want to be. However, in the moment, we primarily need to solve the first point, getting better data first. What I want to end with is that I thought about potential for collaboration within FINROP, and I basically structured that in two parts of what I think what we need and what we can offer. So in terms of what we need, I think I've stressed that sufficiently. So anything in terms of data on management or technology usage, so what, when, where, how is used, as well as environmental outcomes from real farms, ideally, or also from research stations. So if there is any information from research station where what technology is used, then that would also be really interesting and useful for us. In general, approaches to detect technology and management from remote sensing would be interesting, and that is something that we are already working on. And thirdly, and I think most importantly, and I think that has also interesting connections to the previous talk, which is already a great example in this respect, is approaches to measure or approximate outcomes, so yield, but most importantly, the environmental performance on environmental indicators. Maybe I mentioned open calling 2 here, so maybe that is also something that would be useful here. In terms of what we can offer, as I said, I think in general, we in our group also in general as economists in FinoRob, I think what we cover is the perspective beyond the research station, so the pharma or the regional scale. And I think we also have tools and equipment or knowledge of how to identify causal effect from observational data, so working with non-experimental data, so with the fact that behavior might not be randomly assigned. So we have the tools and knowledge to work with that data. And I think in terms of the output, I think what we can offer is, or at least that is what we are aiming at, is feedback for technology development on farmers' objectives and decision making. And with this, I'm done, and thank you, and I'm looking forward for the question and discussions.